Here we will draw the major tracts of the spinal cord, specifically the posterior column pathway, the anterolateral system, which includes most notably the spinal thalamic tract, and the lateral corticospinal tract. First, draw an axial cross-section of the ovoid outline through the spinal cord. Then draw the gray matter horns. Divide the posterior column in half, and then include the central canal. Next, label the anatomic right and anatomic left sides of the page. Now on the right side, draw a mixed spinal nerve. Then on the left, label the primary motor cortex and label the primary sensory cortex. Include a table so we can keep track of key elements of the major tracts. Now let's draw the posterior column pathway. Shade the posterior column in the posterior funiculus of the spinal cord. To begin, add a dorsal root ganglion to the mixed spinal nerve and indicate that proximal to the dorsal root ganglion, the posterior division of the nerve becomes the posterior nerve root. We address nerve root anatomy elsewhere. Show that the first neuron we come to along the path of the posterior column pathway, the first order neuron, which we abbreviate as 1-PCP, lies in the dorsal root ganglion. Next, show that the second order sensory neuron lies in the gracile and cuneate nuclei in the medulla. Then show that the third order sensory neuron lies in the contralateral thalamus in the ventroposterior lateral nucleus. Now draw the posterior column pathway itself. Indicate that the central process enters and ascends the posterior column without forming a synapse in the spinal cord, and that it instead first synapses in the gracile and cuneate nuclei in the medulla. Next, in midline, label the internal arcuate fasciculus. Then show that the gracile and cuneate nuclei send decussating fibers across the medulla via the internal arcuate fasciculus to synapse in the thalamus. These fibers ascend the brainstem via the medial lemniscus to complete the brainstem course of the posterior column pathway. Finally, indicate that the thalamus projects to the sensory cortex. Note in our table that the posterior column pathway ascends the spinal cord ipsilateral to its side of origin. Now let's draw the anterolateral system pathway. Shade the anterolateral system in the anterior funiculus of the spinal cord. Indicate that its first order neuron lies within the dorsal root ganglion. Its second order neuron lies within the dorsal horn of the spinal cord, and its third order neuron lies within the contralateral thalamus in the ventroposterior lateral nucleus. Next, draw Lissauer's tract in between the dorsal peel surface and the dorsal horns because the anterolateral system fibers ascend or descend a variable number of spinal levels within Lissauer's tract prior to synapsing in the dorsal horn. Then show that the anterolateral system projects centrally from the dorsal root ganglion into the dorsal horn. Now draw the ventral commissure between the anterior gray matter horns. Show that at or near their level of entry into the spinal cord, the anterolateral system fibers decussate via the ventral commissure and bundle in the anterolateral spinal cord, where they ascend the spinal cord and brainstem to synapse in the thalamus. Finally, show that the thalamus projects to the sensory cortex. Note in our table that the anterolateral system ascends the spinal cord contralateral to its side of origin. Lastly, let's draw the cell bodies and pathway for the lateral corticospinal tract. Shade the lateral corticospinal tract in the lateral funiculus of the spinal cord. Indicate that the prototypical first-order neuron lies in the motor cortex. Next, draw a spinal motor neuron within the contralateral anterior gray matter horn of the spinal cord and label it as the second-order neuron. Now label the cervical medullary junction. Show that lateral corticospinal fibers descend from the motor cortex through the ipsilateral brainstem, decussate within the medullary pyramids at the cervical medullary junction, and then descend through the spinal cord in the lateral corticospinal tract to synapse and spinal motor neurons. Then show that the spinal motor neuron projects motor fibers via the anterior nerve root to form the motor division of the peripheral nerve. Note in our table that the lateral corticospinal tract system descends the spinal cord contralateral to its side of origin. This concludes our diagram.